So if we've got a bin and we're adding air cannons, do we need to add bin vents as well because we're firing into these cones and hoppers?
That question comes out a lot. The only time it's ever been a factor is in when there's not much ventilation. It's a sealed bin, and what is the volume? So our tech data sheets shown from the web page would give you the volume at whatever PSI we're operating the cannon, 60, 80, 100. That compressed air, that volume will be introduced inside the vessel instantly. Whether your vents can handle that discharge or not is up to process the application. I have not come across an application to where the cannon's discharge was too much for the process. The question comes up, but the issue doesn't, in my experience.
In my experience as well, I'm going to chime in on that as well. So every customer that's ever asked me, yes, it's a slug of air. I call it a slug of air, but as soon as it leaves our vessel in that nozzle port, that air is dissipating, and that volume of dissipated air really would not cause an overpressure on any hopper or bin in the time that I've done it as well.
That's a good point. And one thing that I will interject as well, a lot of times where we have automated systems, there are instances where you have hoppers, cones, or even live feeders. We won't fire those cannons until a discharge or process is open and running. We have to have a place for the material to go to. If you have a rotary valve and you've got your cannons firing before the rotary valve opens, that's going to be a problem. That's not going to be a solution. So timing and how those air cannons turn on, whether it's a single cannon or multiple cannons, and your sequence start is inevitably connected to the discharge being open and places for that material to exhaust to.